So the last thing that I want to go over with you is ions. So if we remember what an ion is, if we look at potassium, potassium plus one ion, what does that plus one mean? Well, let's just start by writing out, again, our symbol. So potassium is a weird one. It has the symbol K, and that K has a charge of plus 1, right? We put the charge in the top right, and if I go to my periodic table, I'm not going to show you because I think you know how to find this by now. I know that potassium has an atomic number of 19, and typically when we find that in nature, it has a atomic mass of, it looks like 39 is what is most commonly found. So let's go ahead, let's write that potassium orbital notation and electron configuration. So I have 19 electrons that I actually need to map for this. So let's just fill in those arrows. Still have 2 in that 1s. I have 2 in the 2s, so that's 4, 5, 6. Here comes number 7, 8. Now I start pairing them up. 9, 10, 11, 12. Keep working my way up. 13, 14, 15, 16, 17, 18, and one more in that s orbital. So now if we notice, the next orbital would be actually the 3D. So students sometimes get a little bit confused on why that 3D pops up all of a sudden, and it seems like we shifted into the 4s. The reason for that, and hopefully you realize, is that 3D has a little bit more energy than the 4s, and a little bit less energy than the 4p. So just kind of be aware of that 3D does sneak in there, but it's all, again, due to how much energy it takes for that electron to kind of sit in that orbital. So let's translate that to our vertical form. So same as before, I'm going to have 1s, I'm going to have 2s, I'm going to have 2p, and I'm just filling in those arrows. Kind of a tedious job here, but we got to represent every arrow. And I didn't do them separately there. I'm kind of speeding through this a little bit. You really have to be careful that you're not doubling up before you absolutely have to. So shame on me, but I'll do better the next time here. You really run the risk of accidentally pairing them up beforehand. Here, I'll fix it right here. This is our 3p. 1, 2, 3, 4, 5, 6, and then we have that 4s, and there's one electron in that 4s. So what I have drawn here, remember, is potassium 19, but the difference here now is that I have a charge of plus 1. So what does that plus 1 mean? I have to remember that. It means that I've either gained or lost electrons. And remember, if I take away that negative electron, it's going to leave me with a positive charge, right? My positive charge of plus 1. So that means I took away an electron. So I've taken away this 4s. Let me just get rid of it. Oh, why can't I get... Oh, I want everything. There we go. Go away. So my electron configuration is going to show one less electron. So it actually acts like it has 18 electrons. What element has 18 electrons? I'll let you look. Argon, right? So the potassium plus 1 is actually going to have an identical electron structure, electron configuration as argon. So then I'm going to go through. Let's go ahead and let's just write that electron configuration out. 1s2, 2s2, 2p6, 3s2, and then 3p6. Now, let's look at our dot diagram. How many dots do I have in that diagram? Well, looks like I've got in my outer shell, in that third shell, I have 2 plus 6 gives me 8 electrons. 8 electrons, which is actually the maximum. They don't want any more than 8. Once they get 8, they're pretty happy. So again, let's keep those quadrants in mind, top, right, bottom side. I'm going to have 1 electron, 2, 3, 4, 5, 6, 7, 8, pairing up only when I have to. So this also, we represent the fact that this is not normally how potassium looks. We put a little plus charge, a little +1 charge, or just a plus charge. It means the same thing. So what I want you to do, I'm going to post this video on Classroom. If you need to see it again, please pause, rewind. I have headphones in the classroom. Please finish this up and get some practice with writing these valence electrons, writing the electron configuration, and the orbital notation. Thank you.